block sitting on a ramp, and our job is to figure out what the acceleration of the block is going to be. We drew the forces. We know gravity parallel pulls down the hill, friction's pulling back up the hill, normal force and gravity perpendicular are in the positive and negative y directions. So now what we need to do first is figure out, all right, which way is this thing going to accelerate? Well, any object that's on a hill, unless it's being pushed, and this is not, is typically going to go down the hill. So we're going to write down our equation in the x-axis. And I'm going to say down the hill to the right is positive, up the hill to the left is negative. And what that will give me is an equation of force of gravity parallel minus the force of friction equals ma. Now we have everything we need in order to solve for force of gravity parallel, because the equation for that is sine of the angle, which we have, times mass given times 9.8. We have the mass and we're looking for acceleration. So the issue here is friction. And here's why that is an issue. We, again, know what force of gravity parallel is, or at least we could easily find it. But for friction, the equation for that is the coefficient times the normal force. And while the normal force is here, we don't know what it is. The coefficient is given. It was given in the problem as 0.4. So before we can actually solve for the acceleration, we have to solve for the normal force. And to do that, we solve in the y direction. So in the y direction, we know that the normal force goes up and force of gravity perpendicular goes down. We also know that this thing is not accelerating in the y-axis. It's not accelerating up and down in that y direction. So we know that the normal force is up. We know gravity perpendicular is down. And we know this is not accelerating, so they add up to be 0. And what that tells me is that the normal force equals my force of gravity perpendicular. And we have an equation for force of gravity perpendicular, which I'm going to use, and that is the cosine of the angle of the hill, which is 35 degrees, multiplied by the mass of the object, which is 5 kilograms, times 9.8 meters per second squared. And when you plug that into your calculator, you get that the normal force is equal to 40.14 newtons. Now I have enough information to go back into my x direction equation and solve for what I want. So my force of gravity parallel, that equation is the sine of the angle, which is 35 degrees, times the mass, which is 5 kilograms, times 9.8 meters per second squared, minus the coefficient, which is 0.4, times the normal force, which is 40.14, and I'm going to divide this mass over here to the other side, and that is 5 kilograms. And all of that equals the acceleration. So when we plug all that into our calculator, we get an answer of 2.4 meters per second squared for acceleration. So we can't solve in the x-axis right away. We needed to know what the normal force was. And to do that, we went into the y direction, solved for it, and then we did our x direction stuff, just like we've been doing for quite a while. The end.